You know what really holds our world together? And I'm not talking philosophically here. I mean the literal stuff, the glue in our furniture, in our homes, in our offices. Today, we're going to dive into a pretty amazing scientific breakthrough that finds a super powerful, sustainable solution in a place most people would just, well, call trash.
Sounds kind of weird, doesn't it? But seriously, what if I told you that taking plant waste, yeah, like old corn husks, and turning it into a high-performance glue isn't some sci-fi fantasy? It's actually the future of how we make things. And it all kicks off by tackling you guessed it, a very sticky problem. So let's set the stage a little bit. We're talking about plywood. It's a material that is absolutely everywhere. And the secret to making really good plywood? It's all about having a really, really good glue.
For decades, the undisputed champion of glues has been something called phenol-formaldehyde resin, or just PF resin. This stuff is incredibly strong, it's water-resistant, and it gives us the durability we need for everything from our kitchen cabinets to the actual walls of our homes. It's kind of the invisible hero of the modern world. But, like any hero, it's got a bit of a flaw.
Okay, so here's the deal with this standard superglue. There are a few big problems. First off, its main ingredient, phenol, it comes from petroleum. You know, a non-renewable resource we're trying to use less of? Second, it's pretty pricey. And third, and this is a big one, the whole process uses some toxic chemicals like formaldehyde, which can get released into the air we breathe. So that leaves us with a huge question. Can't we do better than this?
Well, it turns out the answer might be hiding in plain sight, sitting in the waste piles of farms and paper mills. So let's meet the hero of our story, a complex, natural polymer called lignin. It's been overlooked for years, but believe me, it is about to get its moment in the spotlight.
So what in the world is lignin? The easiest way to think of it is like nature's concrete. It's the stuff that binds all the fibers in a plant together, making trees and corn stalks stiff and strong. And here's the really cool part. It's everywhere. I mean, industries like paper production and biofuel create tons and tons of it as a low-value waste product. It's renewable, it's cheap, and it's just sitting there, waiting for us.
Now, you might be thinking, if lignin is so great, why haven't we been using it all along? And that's a fair question. The reason is that it's just really complex. Its chemical structure is super messy, and it changes from plant to plant. Early attempts to just kind of swap it in for phenol, well, they didn't go so well. The glues were weak, unreliable, and they just couldn't compete. It was a puzzle nobody could quite solve.
And this image right here illustrates the problem perfectly. This is a peek at lignin's chemical signature. You don't have to be a chemist to see that this isn't some simple, clean line, right? It's a chaotic jumble of peaks and valleys. For years, scientists saw this as a roadblock. But what if it wasn't a roadblock at all? What if it was actually a roadmap?
Because that complexity is exactly where the big breakthrough happens. A team of researchers decided to just stop guessing and instead start precisely mapping that crazy structure to finally unlock its real potential.
So what was the big secret? How do they turn this unpredictable plant gunk into a high-performance glue? Well, it wasn't about trying to change the lignin itself. It was about finally, truly understanding it for the very first time.
They came up with this really brilliant three-step process. Okay, step one, they used a super advanced scanning method. It's called phosphorus 31 NMR to get a crazy clear picture of the lignin's chemical structure. That let them move on to step two, actually counting the exact number of what they call active sites. Think of these as the tiny little hooks where the glue can really grab on and form a strong bond. And once they had that magic number, they could nail step three, creating the perfect recipe, adding just the right amount of everything else to get the chemistry just right.
And believe it or not, it all came down to this one number, 1.72. For the specific corncob lignin in this study, that was the magic number. It told the researchers exactly how reactive their lignin was, which meant they could design an adhesive with incredible precision, instead of just using guesswork. This one little number was the key that unlocked the whole thing.
Okay, so having a good recipe is one thing, but the proof is always in the pudding. Or, I guess in this case, the plywood. So how did this brand new, precisely made lignin glue actually hold up when they put it to the test?
And the results? Wow, they really do speak for themselves. The new lignin glue is totally strong enough, it easily meets industry standards. But the real game changer here is the formaldehyde emissions. They're slashed by almost half compared to the regular glue. And if you look at that older, messier attempt with lignin, yikes, the emissions were through the roof. It's so clear that this new method just nailed it, cracking the code for both safety and performance.
This chart right here makes that safety benefit crystal clear.
The new lignin glue produces way less toxic formaldehyde gas than the industry standard. This isn't just a win for the environment, it's a huge deal for the health of factory workers, and honestly, for the air quality inside our own homes.
So to sum it all up, this was just a massive success. The new glue is more than strong enough for industrial use, it's way safer, and get this, it does all that while replacing half of the expensive, petroleum-based stuff with a cheap, abundant waste product. It's a win-win-win.
So what does this all mean for the future, beyond just making better plywood? Well, this is about a fundamental shift in how we think about the materials that literally build our world.
The really big takeaway here is this. By using advanced science to precisely understand a natural waste material, we can turn what we used to think of as trash into treasure. We can make products that aren't just green alternatives, but are actually high-performing, much safer, and even more economical.
And as the researchers themselves put it, this doesn't just give us a better glue, it will greatly improve the economics of using lignin. It basically creates a valuable new market for something that used to be an agricultural byproduct, making the whole system more profitable and sustainable.
And all this leaves us with one final and pretty exciting question. We've just seen how science can turn old corn cobs into superglue. So what other hidden potential is locked away in the waste we throw out every single day, just waiting for us to find the right key?